All right, I've hit record, everybody. So we've broken the ice here in the tutorial. We've sort of introduced ourselves and said hello and talked a little bit about the course. So I thought what we could do now is just to discuss a few basic problems. So I thought we could, let me share my screen. I thought we could talk about these three problems. Now, these are not particularly difficult problems, and I wouldn't expect them to be, in the final exam. But the idea is to, discuss these problems, maybe refresh our memory a little bit, and think about different ways to solve these problems. So some of them would probably look familiar with you. They might look familiar. Maybe they don't. That's fine. Okay, but what I thought we could do to make this a little bit more interesting is to solve these problems using Maple and also solve them by hand. Okay, because I know with a course like this, Maple is a big part of the course, and almost no one is familiar with Maple. Okay, so this is an opportunity to solve some basic problems and learn a little bit about Maple. Does that sound okay to everybody? Let me know in the chat. Yeah, okay, great. Thanks, folks. Now, I must confess, I'll go back to my big fat head, I'm not an expert on Maple, but the way this course is structured, week by week in the Mobius lessons, you get a little bit of Maple, okay? And you can do a lot in this course just knowing maybe 10 commands or maybe 20 commands, okay? So let me show you how to solve these problems using Maple, and then I'll do them by hand as well, okay? All right, so let's look at the first one. Solve an inequality for x, okay? So we want to find all those values of x that make 1 on x greater than or equal to a half. All right, so let me pull the Maple window up, and I'll show you some of the really cool things with Maple. Okay, so let me know in the chat what you think, or let me know. All right, so if I put in the solve command, right? Hopefully you can all see that. Let me know if you want the font a bit bigger. How's that? That's better. All right, so let's do a bit of coding here. Solve 1 on x is, so I'm going over to the left to choose the greater than or equal to sign. 1 on x is greater than or equal to a half. Okay. All right, so that's a command that I'm giving Maple. The command is the solve command. And the wonderful thing about Maple is that it can solve inequalities, right? Now this little thing at the end is just to tell Maple I want to see the answer, okay? So if I press return here, dun, 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 what does that answer actually even mean? Can anyone tell me in the chat or otherwise? Maple's given us an answer in blue, but what is it? How could we interpret that? Let me know. What does this answer actually mean? Yeah, and I like your explanation. Yep, and Marco, x is between 0 and 2, exactly. 0 is not included, absolutely. So if I was writing it, it would be something like this. 0 less than x less than or equal to 2. Okay, so that's a very simple thing, right? The solve command, I've put in some brackets, and I've got an inequality in there. Now, see what happens if I do sorry, I'll do it for another one. Okay, so let's do this by hand and see if we can do it. Okay, I'll just go back to my, where are we? Just give me a moment. Oh, there we are. Okay, so let me just go back here and I'll share again. All right, so let's say we're doing this the old-fashioned way, right? And I want to solve for x, and it's 1 on x is greater than or equal to a half. All right, so let's highlight that. Now, there's a few ways that we can solve this. Can anyone suggest on the chat one strategy for solving this problem? Any ideas on the chat or on the mic? How might we strategize this? What might be a method? We sort of, Maple's given us an answer, but it hasn't told us how to do it. Any ideas? Cross multiplication, Azad. Yeah, take x over to the right and 2 to the left. Yep. So all those sound pretty good. So the first thing I'm going to do is that I'm going to identify here, we're not, we're excluding x equals 0 because obviously, this doesn't make sense if x equals 0. Right. So there's some really good suggestions on the chat. I'll show you two ways to do this. What I would like to do is simplify this, okay? And people on the chat have mentioned cross multiplication. What I'm going to do is I'm going to multiply both sides by x squared. Now, the reason that I multiply by x squared is because x squared is positive. If x is not 0, then x squared is positive. And if I multiply both sides of an inequality by a positive number, I don't have to worry about flipping or changing the inequality sign. Okay? So let me just squeeze something in there. We have this. And so we can cancel off. So that, and as someone suggested in the chat, we can multiply both sides by 2, which is a positive number, and we'll get something like this. Now, let's rearrange that. And I can factorize it. So this is a common idea now. All right. So what I've done there is I've gone, okay, let's transform this into a simpler problem. Okay. So one way to do this is to go, okay, I can draw the graph of this function pretty easily. If this is my x and this is my y, and let's just draw in it's a parabola. Okay, and now the question is, where does this graph lie below the x-axis? Well, it's in here, isn't it? So they're the values of x that I want. Okay, so even though the graph suggests x is between 0 and 2, I've excluded 0 over here. So x is actually greater than 0 and less than or equal to 2. Okay. So this is a standard technique, and we basically transformed the problem by simplifying the expression. All right. Now, there is another way of doing this problem, which is much simpler than this one. Okay. And Azad talked about cross multiplication in the chat. So what you can actually do is start here and go, right, 1 on x is greater than or equal to a half. So, and 1/2 is greater than or equal to 0. So what does that mean? It means that one on x is greater than 0, i.e. x is greater than 0, right? And so what that means is that you can actually multiply both sides of this by x because you know x is positive. So if I multiply both sides by x, I get something like this. Bring the 2 up there. Oops, sorry. So we have, from that analysis, this and this. If you put those together, you get, oh my goodness, that. Right? Now, this is called the transitive property of inequalities. So if that's bigger than that and that's bigger than that, this has got to be bigger than that. And so you can make a statement, okay? You can't always do this. This is the safest bet, right? But this can save you a lot of time, okay? So let me go back to Maple just for a second because I want to show you another way to do this problem using Maple, okay? So I'm going to show you the plot command. So plot command basically draws a graph, okay? And for this kind of problem, I'm going to plot the graph of 1 on x, and I'm going to plot the graph of y equals a half, okay? So I can do that using square brackets. You're sort of producing a list of things you want graphed here, okay? So let me just do that and watch what happens. So I'm using the plot command, okay? So Maple is great because you can use it to plot. Let me make this a bit bigger. Okay, that looks pretty good. So the red curve is 1 on x and the horizontal blue curve is 1/2. So remember, we're solving this inequality here. 1 on x is greater than or equal to a half. So where is the red curve above the blue curve? Well, it's in between these x points. So that's another way of solving that problem, which Maple can help us out with, right? So what do you think so far? We've learnt the solve command, spits out an interval in this case, and we've learnt the plot command. Not too hard, right? I mean, Maple, once you know a couple of basic commands, Maple is pretty good, pretty good. So are there any questions for that particular example? I've shown you 2 ways to do it by hand and 2 ways to do it using Maple. What do you think? Maple's not that scary, right? If you forget some of the symbols or some of the commands, you can choose from this, this thing on the left, right? Sometimes I forget as well. Okay. Where is? Oh yeah, no, it's on the web. Okay. All right. So what about this problem? Solve cosine x equals sine x for x in the real numbers. Okay. So this funny R means the set of real numbers, and this means the backward looking E means belongs to or is an element of. Okay, well, let's go to Maple first on this one. Okay, so I'll go into Maple and I'll do pretty much what I did up here. Okay, so I'm going to do solve cosine x minus sine x and see what happens. Pi on 4. Or actually, I can put, sorry, that's what it defaults to this. Let me just put that in here. I'll put equals so it's even clearer. Now, can anyone see a problem with what Maple's produced there? Let me know if you kind of oh, interesting choice, Azad. I'm just wondering if the answer that Maple's given us is complete or not complete. It has no working, absolutely. That's for sure, Samuel, yes. But is that the only solution? Is pi on 4 the only solution? Exactly, Samuel. The Maple gives you one solution, but there are many others. So let me give you an example. We'll use the plot command again. And I'll plot cosine x and sine x on the one set of axes. Okay. Watch what happens. Make that a bit bigger. Okay. Whoops, too big. All right. So you can see there's a solution whenever the red and the blue curve touch. Okay. So there's a solution there. There's a solution there. There's a solution there, and there's a solution there. But Maple says, well, pi on 4, yeah, that's a solution. What about all the other solutions? So the point I'm trying to make is that Maple's good, but it can't do everything. Okay, it cannot do everything. So what can we do about this? Well, we can use Maple in a slightly more creative way, I guess, by drawing pictures and drawing graphs. So let me show you what I mean. This equation, can anyone tell me on the chat, what is an equivalent version of that equation involving tan? Can anyone tell me what the equivalent equation is involving tan? Let me know on the chat. All right, Marco, Samuel, yes, legends. Tan x equals 1. So if I plot, say, tan x, and I plot the constant function 1, okay, let's put those on the same set of axes. Watch what happens. Oops. Oh, I didn't want that. Okay, it's a little bit harder to see. I've sort of squished it, but I can get it back. Okay, that's better. All right, so you can see the horizontal line is the constant y equals 1, and these curved red lines are the tan function, and the vertical red lines are just asymptotes, so don't worry about those. But you can see every time these two curves cross, that's a solution. Okay, so there's an infinite number of solutions. This is just between -2 pi and pi. But Maple can't tell us that. Okay, but by drawing a picture, we can understand the solution set better. We can understand the problem and the solution better. Okay, so what's the answer going to be? All right, well, let's have a look at our pictures again. Okay, so if I look here, that's pi on 4. right? And if I go up here, that's up here, that's pi plus pi on 4. Okay, you can count the number of like markings. And over here, that's pi on 4 minus pi. So we get a whole bunch of solutions, right? So our solution set is going to be pi. Right? Sorry, pi on 4. Pi on 4. Pi on 4 plus pi. Pi on 4 minus pi. And so on, right? It's going to just continue on. Plus 2 times pi. Minus 2 times pi. So that's we're going to get an infinite number of solutions there. Okay. So not just one that Maple told us, but we actually get an infinite number of solutions. Okay. Now there's other algebraic ways of solving this problem. Cosine x equals sine x. I won't do that, but let me just do another problem because we're sort of running out of time. Hang on. Yeah. I wanted to do this problem here. Okay. Now this looks difficult because it's got an absolute or 2 absolute value signs in it, but actually it's not that difficult. So let's go to Maple and see what happens. Okay, so I'll get rid of that. Okay, so who can suggest what would our command be in the chat based on what you've seen? Who can tell me? Come on, smash that chat button. Let me know. We've used a couple of commands so far. What do you think a command would be for this third and final problem? Ahan, yes. ABS for absolute. Great job. We've also got that up there if we forget in the top left-hand corner. That's absolute. We could plot it. Yes, absolutely, Samuel. Let's do solve first. Okay. So absolute, what was it? Let me check my notes here. Yeah, okay. Absolute x minus 1 all over absolute x plus 1, and it was less than 1, wasn't it? Okay, let's see what Maple says, and then we can plot it like Samuel suggests. Okay, what does that answer mean? Who can tell me? Let me know in the chat. What Maple's given us an answer. Let's interpret it. What does it actually mean? Exactly, Azad. So it's x is positive and less than infinity. So basically x is just positive, right? So that's fine. So let's plot that. Let's plot that, and let's see what happens. Ooh. Okay, let me make that a bit bigger. Okay. So exactly, Ivy. Thank you. X is greater than 0. Right. Perfect. So let's have a look. We want to work out where this is. The graph of that function lies below 1. So the red function is this absolute value function type thing, and this is the region where the red curve is below the blue curve. Okay, so you can see Maple's pretty cool. So how would I go about doing this algebraically? Well, I'm glad you asked. So I'll do that and then we can finish. So we want to solve for x. So we've got, what is it? X, absolute x minus 1 over absolute x plus 1 is less than 1. Okay, so the absolute value function is always, it can never be negative. So what I can do is multiply, say, both sides by the denominator, which is always positive. So I can write it like that. Like that, okay? So I've multiplied both sides by this, which is always non-negative, right? Okay, here, of course, we would say x cannot be equal to -1. All right, so you got that and that. How can we simplify this? Well, let's try to get rid of the absolute value signs, right? So we can square both sides. And the reason that we can do that is because that is greater than or equal to 0, and that's greater than or equal to 0. So when we can square these things and keep the same inequality. Okay, now if you square an absolute value, it's just the same as squaring them without the absolute values. So you can see what we've done now is very similar to the earlier problem. We've taken something difficult and transformed it into an easier problem. Okay, so let's expand these brackets and simplify. Okay, so we've got an x squared over here and x squared over there. Bam. We've got 1 over there and 1 over there. Bam. Take that to the other side and you're going to have this. So how do we solve this? Well, it's just divide both sides by 4. That's it. Okay. So that's one algebraic way of doing it. You can square both sides immediately if you want to. I just rearranged it a little bit. So I've shown you how to use Maple to solve these problems. We get the same answer, thank goodness, as Maple. Maple's very fast. It can't tell you everything, and here's an algebraic way of doing it. Okay. All right, folks, I'm going to stop the recording, but I'll hang around for a few more minutes just in case you want to chat for a while, okay? So nice to meet you all. I'll hang around and have a great weekend, and I'll stop the recording now.